Elasticities have many uses in economics. The one you are probably most familiar with from Econ 1000, it would be the price elasticity of demand. There are other kinds of elasticity, income elasticity, price elasticity of supply. These are all very important and they come up in economics in many different situations. I'd like to walk you through an example, an application of price elasticity. One, a numeric example. And then once we're finished with the numeric example, we'll move into calculus, where we're going to compute elasticities when the rate of change is very small. Like in the section we just finished about approximation, elasticities work best when the change in the variables is small. That's going to give us the most accurate measure of how responsive quantity is to changes in price. And so looking at the example on the slide in front of you, we see that in January 2011, Netflix cost $10 per month until later in 2011 when they increased their price to $16 per month. So it's quite a big increase. Now we know the law of demand tells us that if a company here, Netflix, raises its price, the quantity demanded is going to fall. The number of subscriptions to Netflix should fall. But another important question, or maybe a more important question from Netflix's point of view, is did this price increase increase revenue or decrease revenue? And to answer that question, we could use the price elasticity of demand. And so let's take a closer look at this numeric example on our next slide. We have our Netflix example here. They've raised their price from $10 to $16. And I've got to round up from $15.98 to $16 to make the numbers a little more manageable. And we've been given an extra piece of information, which is that we're to assume the quantity demanded decreased by 25%. What was the percentage change in revenue? Well, one thing that I could do without knowing what the initial quantities are is I could take advantage of these relative rates of change I've been given. I know the relative rate of change in the price is going to be, well, it looks like it's going to be about 60% increase, right? It's going to go from $10 to $16. That's a 60% increase. And the quantities demanded are going to decrease by 25%. So I could write R new is going to be equal to the old price multiplied by 1.6. That's 1 plus 0.6. 1 is representing the starting value of P, and then adding 0.6 to represent the 60% increase, multiplied by our initial quantity demanded, whatever that is, multiplied by, I'll write it out this time, 1 minus 0.25. And so we get R new is going to be equal to 1.6p times 0.75 Q. And if I simplify that a little bit more, I'm going to end up with 1.2 price times quantity. And looking at that, you can see the revenue is going to go up 20%, right? Which is rearranging, taking advantage of the fact that there's just one term here. This is just one big term. And price and quantity and their percentage changes are coefficients. You can see that the new revenue is going to increase 20%. And that's kind of how elasticities work. And we're going to look at it with a calculus point of view. This is just actually generating the number. So this is the actual change in the revenue is going to be 20%. But we can use elasticities to approximate the change in revenue. And so why don't we go ahead and do that next?
Now let's start by looking at a demand equation, or perhaps a demand function. So X is the quantity demanded, D is the demand function itself, and the demand function is some function related to price. Here's our demand function. Now suppose I want to find the actual change in X when price changes. So we want to find the actual change in X when the price changes. Let me rewrite that down here. The actual change in X, we denote that with a little triangle X, and that triangle is the Greek letter delta, capital delta, capital letter delta. And that's going to be equal to, well, the demand function, demand as a function of price, plus the change in price, minus the demand function of at the original price level. So that's our actual change in X. And remember, we're using the same terminology as in approximations. So this is the actual change, not the approximation. Keep that in mind because we're going to use calculus in a little bit. Now, if I want to know the relative change in X, well, from chapter 6 we know that the relative change in X is going to be the change in X divided by X itself. And so using the demand function, what's that going to look like? We're going to have the demand function at the original price P plus the change in P minus the demand function at P, and all that divided by X itself, which is going to be dP, the demand function at the original price. This slide here summarizes what we derived before. And where did we end up? We ended up with an expression for the relative rate of change in X, which is the quantity demanded. Remember, X is the quantity demanded. What do we do next? I'm actually going to go back to the previous slide where we've got some space to calculate the price elasticity of demand. Divide the relative change, or what I said before, the relative rate of change in X, or in quantity demanded, how do we do this? Take the relative rate of change in quantity demanded and divide it by the relative rate of change in price. So what we're looking for is we're going to have the relative rate of change in quantity demanded. We want to divide this by the change in price over price itself, and this gives us the price elasticity of demand. Now we can do some rearranging here, so I'm going to take this expression, I'm going to bring it down here, and what's this equal to? Well, it's equal to dP plus the change in P minus dP divided by the demand function. And that whole thing is going to be divided by the change in price divided by P, where of course this is equal to the relative change in price. Now we can simplify this a little bit. So I will move this out from its denominator. So we have price over change in price multiplied by the demand function when price is changed minus the demand function, the original price, over the demand function at the original price. And I'm going to rearrange this a little differently. I'm going to put price over here and the original quantity demanded together, like so. And I'm going to move the change in price to the right-hand side factor. So we have change in P, like so. Why have I done this? Well, notice that I'm going to duplicate this, move it down there. I'm going to get rid of these. Notice this is a Newton quotient. And you'll remember that when we take the limit of the Newton quotient as the denominator, in this case the change in P becomes very, very small. It gets really close to 0, but not quite at 0. We have the derivative. We find the derivative. So if I were to duplicate this, bring it down over here, and maybe I need to move it just a little bit to the right, give myself some room. If I was to take the limit as the change of P approaches 0 of this thing, I would find d prime P, which is of course equal to the change in the demand function with respect to P. And that's our limit. And so that's where calculus is going to come in to our elasticity. Remember, in Econ 1000, there was no calculus, right? And you were able to calculate elasticities without any calculus. But here we're going to use calculus, and it's actually going to make your life quite a bit easier because you can approximate how quantity demanded is going to change. You don't actually have to calculate it. Why is that important? Well, because sometimes actually calculating these things can be very difficult.